Today we'll be looking at finding the surface area, the lateral area, and the volume of pyramids. First off, a regular pyramid is a pyramid with a regular polygon for a base. In other words, all of the sides are congruent in the base to each other. So a square pyramid, a regular hexagonal pyramid, a pyramid with an equilateral triangle. The lateral faces of a pyramid are the triangular sides. Notice this is different than a prism. In a prism, the lateral faces were the rectangles. Here, it's the triangles. So if the pyramid is regular, in other words, if the bases are, all the sides of the base are congruent, then the lateral faces are isosceles triangles. The height of the pyramid is the segment from the vertex perpendicular to the plane of the base. In other words, it goes from the vertex straight down to the middle of the base, and it makes a 90-degree angle with the base. So you can see the purple line is the height or the altitude of the pyramid. The slant height, which we'll denote with an L, is the altitude of one of the lateral faces. So it goes from the vertex down the side to the midpoint of the base, and it makes a 90-degree with the base. So you can see it on all of these. The slant height will be the blue line. So the formulas you need to know to find the lateral area, surface area, and volume of the pyramid are as follows. The lateral area is the perimeter of the base times the slant height divided by 2. The surface area is the perimeter of the base times the slant height divided by 2. In other words, the lateral area plus the area of the base, because there's only one base, so we only need to add in one of them. And then the volume formula for a pyramid is the area of the base, big B, times the height of the pyramid, divided by 3. It's important that you divide by 3 and 2 here. So to review, the slant height goes down the side of the pyramid, and the height goes straight up and down in the pyramid. There is actually one more component. This piece from the vertex down to a vertex of the base is called the lateral edge. So if I highlight it in green, that would be called the lateral edge. Okay, so some important things about pyramids. If I draw the altitude of the pyramid and I draw the slant height and the apothem, it makes a right triangle. So the height, the apothem, and the slant height make a right triangle. Here you can see it again, height, apothem, slant height. Height, apothem, slant height. So that's one of our special triangles inside of a pyramid. You really do need to know this one. So height, which I'll denote as H from here on out. Apothem, which I'll denote as an A. And then the slant height, which I'll denote with an L from here on out. So that makes a right triangle inside of a pyramid every time. So if I give you the height and the apothem and you need to find the slant height for the formula, use the Pythagorean theorem. Now there's one more triangle. If you look here at this one, the height, the radius, and the lateral edge also make a right triangle. I know it's abstract, it doesn't look like a 90, but if it was standing straight up and down, it would. So the height, the radius, and the lateral edge is a secondary triangle inside of it. And we'll use that triangle whenever we are given the lateral edge in a problem, because we're going to need to be able to find the rest of the components. So we got the lateral edge here, which I'm going to denote as x from here on out. We have the height, so that's in the same place actually, which makes it a little convenient. And then the radius, which I'll denote as r. So these two triangles are ones you're going to want to know. If I give you the lateral edge and the height, if I give you the lateral edge and the radius, then you can find the height. And with the height and the apothem, you can find the slant height. So we're going to do a problem in a bit where we work through both of these triangles. So let's try out some examples. Let's say we have an equilateral triangle as the base of a pyramid. The side length is 8 root 3 centimeters, and the slant height is 12 centimeters. And I want to know what the lateral area is, what the surface area is, and what the volume is. So I'm going to start by doing my charts and writing out my formulas. with the variables, just like we did on prisms, except for, of course, the formulas are all different now. So this is a good way to keep your work organized and know where you make mistakes and also where you're doing things right. Okay, so let's draw the base. So it's an equilateral triangle. The sides are 8 root 3. So I know right away then that the perimeter is 24 square root of 3, because 8 times 3 is 24. Next up, it tells me in the problem that the slant height is 12. So I can fill that in. So with that being said, I can actually do the lateral surface area. 24 root 3 times 12 divided by 2. 24 times 12 divided by 2 gives me 144 square root 3 centimeters squared. Now we need to figure out what the area of the base is. So whenever we're working with a pyramid, I always recommend that we actually use the apothem formula because we're going to need the apothem or the radius to find either the height or the slant height. So let's go ahead and drop our apothem. It's a triangle, so 30 degree goes here, and then 4 root 3 will be half of the side. And that's the 60 degree side. So to go from 60 to the 30, I divide by root 3, and I get the apothem is 4. So think back for a second. Well, let's actually find our area of the base, because we can do that. So area of the base equals apothem times perimeter divided by 2, which gives me 48 square root 3. Now all that's left is for us to find the height. So let's think of those special triangles that we talked about in the last screen. We were given 2 of them. We need the height, so we can call that h. Now we know the apothem. So which triangle involved the apothem? Look at that triangle. And that is the one with the 4 here, and the slant height is 12. We have 2 sides, so we have enough information to use the Pythagorean theorem to find the third side. So it's going to be 144 equals 16 plus h squared. 128 equals h squared. Square root that, so 64 times 2. 8 root 2 equals the height. And now we just plug in and finish this off. 24 root 3 times 12 over 2 plus 48 root 3 gives you 192 square root 3 centimeters squared. Here you're going to do 48 root 3 times 8 root 2. So 48 times 8 gives you 384 square root 6 divided by 3. Don't forget to divide by 3, which gives you 128 root 3 centimeters cubed for the inside. So that's a way, if I give you the slant height and the base, to figure out what the height is, to use that special triangle that we learned about inside of a pyramid. All right, let's look at one more example here. Let's say we have a regular hexagonal pyramid. So it's a hexagonal pyramid with side lengths of 6 feet. The lateral edge equals 12 feet. And I want to know, once again, the lateral area, the surface area, and the volume. So we organize our work just like that. So PL over 2, P equals L equals PL over 2 plus big B, P equals L equals big B equals, and then big base times height divided by 3. All right, so let's draw the base here. It's a hexagon. That's not a great hexagon, but it's a hexagon. The side lengths are 6, so that means the perimeter is 36. Now I don't know the I don't know the slant height, that's what L is, but I do know the lateral edge. So let's go ahead and work our hexagon and break down the components we know. So 60 goes there, so half will be 3. 3 root 3 for the apothem. And to go from the 30 to the 90 side, you do 6. It's important that we find the radius sometimes still. So let's think to our 2 triangles. Let's just say we want to start with the ones we just did on the last slide. Well, we need the height. We don't have that yet. We know the apothem's 3 root 3, but we don't know the slant height. So we have 2 variables there. So let's look at our other triangle then. This one's the lateral edge, which we know is 12. The radius, which we know is 6. And the height, which we don't know. So we can actually use this information here to find the height. So we do the Pythagorean theorem. So 144 minus 36 gives you 108. Square root that, and you get 6 root 3 as the height. Oh, look at that. We just solved for h, 6 root 3. Now, we use that 6 root 3, and we plug it in here. Now, do we have enough information to solve for the slant height? We do. We use the Pythagorean theorem. So 3 root 3 squared plus 6 root 3 squared equals L squared. 3 squared is 9, times 3 is 27. 6 squared is 36, plus 3 is 108, equals L squared. Add those up, you get 135 equals L squared. And when you square root that, let's see, 9 goes into that, 9 goes in there 15 times. So it's going to be 3 root 15 is the slant height. So yes, it took a lot of work to get there. And yes, we had to use both the triangles. You want to figure out which triangle you know at least 2 parts for. Now the area of the base, we can just simply plug in apothem times perimeter over 2, which is 54 square root 3. And we've now solved for all of our variables, and we just have to finish off the problem now. So 36 times 3, 108 root 15 over 2, gives you 54 root 15 feet squared. So PL over 2, so 54 root 15 plus 54 root 3. Well, those don't combine, so that's feet squared. And then finally here, we're going to do area of the base times the height divided by 3. Well, 54 times 6 gives me 324. Root 3 times root 3 is 3, divided by 3. Those cancel, so you get 324 feet cubed. So please practice the homework. Make sure you practice with those triangles, especially if you have to work backwards, use the formula. Good luck, and thank you for watching.